Hello everyone, this is Anil. In this video, we will solve some of the numerical problems related to block diagram reduction technique. So, in block diagram reduction technique, we will be given the block diagram and we are asked to solve the transfer function. Okay, transfer function is output by input. So, for a block diagram, in order to find transfer function, in numerator, we will focus on forward path, and in the denominator, we focus on feedback path. So, the moment you see the block diagram, identify the forward pass and feedback pass. So we see here this is one of the forward path and this is one of the forward path. You can clearly see that in both the forward paths G2 is common. So one forward path is G1 G2, one forward path is G3 G2. Okay, so G2 is common, so G1 plus G3 times G2. Or you can interpret in this way, since G1 and G3 are in parallel, we can add G1 plus G3 times G2. This completes your numerator part. Now coming to denominator part. So for denominator part, let me erase it. Okay. So now coming to denominator part. Okay. Identify the loops. So you can clearly see here, this is one loop. Okay. So I'll name this loop as L1. Loop L1. Okay. And we have one more loop like this. So we have to reach the starting point. Okay. So I'll name it as L2. Okay. So in denominator, we start like this. 1 minus. Okay. So 1 minus, we have already here, we already have here minus sign, so minus into minus plus. In loop L1 we have G2 times H1, so this is your L1. Okay, G2 times H1. Now in L2 again we have to multiply with minus sign. Already we have here minus sign, so minus into minus plus. And we have in L2 we have G1 G2 and H2, that's why I have written here G1 G2 and H2. Okay, so this completes your first question. In the second question we are asked the gain. Okay, if you see the problem here, we have two paths here. This is one path. Okay, this is how one signal is added, other signal is this one. Okay, so in this signal we see here two blocks are connected in series, so we have to multiply here. So 20 times 2 is minus 40. Already we have here minus sign, so minus into minus plus, so plus 40 here. Now coming to this path, these three blocks are connected in parallel and we have taken here feedback path. Same way here two blocks are connected in parallel. Okay, sorry, it has to be forward path only. Let me erase it. So these two blocks are connected in parallel and we have feedback path here. Okay, so since the blocks are connected in parallel, we have to add it. So 20 plus 30 plus 20, 10 60. Okay, 60, and we have feedback path, so we have to start writing 1 minus. We already have here minus sign, so minus into minus plus. Forward path we have 60, in feedback path the gain is 1, so 60 into 1. So I already solved it, so you get roughly 1. Okay, so this overall we get as 1. Now focus on second part. So these two blocks are connected in parallel, so we have to add it. So 20 plus 0, sorry, 12 plus 0, 12. And we have 1 minus, already we have here minus sign, so minus into minus plus. Forward path we have 12, in feedback path we have 1 by 4. Okay, so when you solve it, you get the answer as 3. So this overall reduces to 3. Now two blocks are connected in series, so we have to multiply. So 1 into 3 is 3. So I written here 3. Finally, we get the gain as 40 plus 3 as 43. This completes your second question. Now coming to third question. In the third question, we are asked here impulse response. Impulse response of a unity feedback control system. Okay, is given by. So we have to ask here open loop transfer function. Impulse response has been given. Whenever you see the impulse response, right? For a impulse response output, Okay, output y in s equal to h in s. So the output y is equal to transfer function. What is h? Transfer function. And the transfer function can be written as ratio of output by input. Okay, ratio of output by input. And I have converted this everything in Laplace domain here. Okay, e to the power minus t. E to the power minus t is 1 over s plus 1. Because of t here, we'll get here square. So s plus 1 square. This minus n comes here. Plus 2 e to the power minus t is 1 over s plus 1. So I have converted everything in Laplace domain. So we have to output y equal to h. H is transfer function. So how do we get transfer function? Just like we wrote here, right? So forward path we have g, and denominator we start writing like this 1 minus, okay, already negative feedback, so we have to take here plus. So forward path we have g, in feedback path is written like unity feedback, so into 1, so g by 1 plus g. Okay, that is thing only I have written here. So and have converted this, right, this thing time domain to Laplace domain, and from this we have to calculate g, open loop transfer function. Open loop transfer function means forward path only g. Okay, so that is what I calculated here, and I have written here note here. Okay, the note explains that whenever we are given closed loop transfer function CLTF, closed loop transfer function, and we are asked for open loop transfer function OLTF, then simply subtract the numerator part in the denominator, you get the answer. The numerator we have 2s plus 1, just subtract it. Okay, so we get here it remains only s square. Okay, s square, and numerator part remains same as it is. So this is one of the shortcut technique. So this completes your third question. Now coming to fourth question. So we are given block diagram and we are asked to solve transfer function. As explained previous, we have to see the forward path. For numerator, we have to focus on forward path. So this is one forward path. Okay. And one more forward path is this one. Okay. From signal to this is one more forward path. In first forward path, we have G1, G2, G3. That's the thing I have written here. In second forward path, we have only G4. Okay. Also, we have to focus on the loops that are not touching. See, in this forward path, the loops are touching. Okay, we have two loops here. This is one loop and this is one loop. Both the loops are touching here. For the second loop, so let me name it as this is L1. Okay, okay, let me use this yellow pen here. So we have this one loop. Okay, this is one loop and this is one outer loop. Okay, so this is, let's say this is L1 and this is L2. If you focus on this forward path, right, for this forward path, L1 is not touching. Whenever the loop is not touching, we have to include that. How we are going to include is that is 1 minus, already we have minus sign here, so minus into minus plus, and we have to multiply these two, g2 and h1, the same thing had written here. Now coming to denominator part, in denominator again same story, you have to start with 1 minus. Okay, we are, so first I included loop L1. In loop L1 we have g2 and h1, g2 and h1. Because of minus sign here, minus into minus plus, and this is your second loop. Okay, g1, G2, G3 and H2. So G1, G2, G3 and H2. Because of negative feedback, we get here positive. And the third L3 is this loop. Okay, let me use different marker. Uh, okay, let me use this one. Okay, so one more loop is this thing. Okay, I hope it is visible. Okay, this is one loop. So you have started here and again you have ended like this. Okay, so let me name it as L3. Okay, L3. So in L3 we have G4 and H2. Okay, G4 and H2. Also focus one thing. This L3, okay, and L1 are non-touching. So two non-touching loop. So we have to start with plus sign. We already have your minus sign in L1. In L3 also we have minus sign. So minus into minus plus, and we have to multiply everything. Here we have G4 and H2. That's why I written here G4 and H2. In L1 we have G2 and H1. G2 and H1. So this completes your denominator part. Very easy. You start with 1 minus, you include loops, okay, L1, L2, L3, and also focus on if any non-touching loops are there, 2, then you add plus sign, and multiply L1 L3. Here L1 L3 not touching, so L1 L3. Okay, 1 minus L1 minus L2 minus L3, because the negative feedback we get here positive, positive, positive. But two non-touching loops start with plus only, because of two negative feedback we get positive, and we have L1 L3 because L1 L3 are non-touching loops. Okay, this completes your fourth question. Thanks for joining. Thank you.